So let us solve this exam questions in March 2016. So this questions is about a piston cylinder devices contain 7.5 kilogram of steam and it has a 0.8 kilopascal of pressure and quality of 0.8. So I write here state 1 P1 is equal to 0.5 MPa is equal to 800 kPa and the quality is 0.85. Please be careful. This questions is about steam, okay, not a gas. Okay, all right. So since the state one is a mixture, saturated liquid mixture, so we write it here as a saturated liquid mixture. So the steam is expand, okay, at a constant pressure until the pressure reach 228. So we draw piston cylinder devices and the piston is moving up to show that the volume is increased. Okay, and we have state 2. Okay, as a pressure 2 is equal to 800 kPa since the process, okay, from state 1 to state 2 is isobaric. Okay, given here T2 is equal to 250 degrees Celsius. Okay, show the PV diagram and determine the total work output in kilojoule. So first we just sketch the PV diagram. Okay, so for the vertical line is P and horizontal axis is V. So I draw a dome with a constant temperature line. Okay, just like this. Okay, next, I want to find total work output. Okay, so how to find total work output? Okay, we know from the definition of boundary work, okay, 1 to 2, the integration from state 1 to state 2, okay, given as a PdV. And since this is a isobaric process, so P V2 minus V1. Okay, so V here is volume. Okay, so how to find V2? We have a formula M multiplied with specific volume at state 2, and how to find V1? M multiply with specific volume 1. Okay, so we look at a state 1, it has pressure of 800 kPa and X is 0.85. So for state 1, I refer to table A5, okay, at P is equal to 800 kPa. Okay, and I use special formula to find specific volume 1. Why I use a special formula? Because this phase is a mixture, saturated liquid mixture. Okay, so for saturated liquid mixture, we have to use special formula. What is the special formula? V1 is equal to Vf plus X Vfg. How to find this value? So refer to A5 at pressure of 800. So you will get Vf, okay, as a 0.0011111, yeah, 111 plus X is a quality 0.85 and Vfg. So you have to minus Vg minus Vf. So 0.24035 minus 0.001115, and you will get the answer for specific volume at state 1, 0.20445 meter cube. And then from here you will get volume for V1 and V1 is equal to 1.5335 meter cube. Okay. Next is to find V2. Okay, V2. So how to find V2? Alright. To find V2, okay, we have to check the phase of state 2. Okay, please be careful for problem involving steam. You have to find phase for each state. So in this question, we know that state 1 is mixture, but state 2, we don't know what is the mixture, what is the phase. So we have to check. Okay, so we have here P2 is equal to 800 kPa, and we have temperature of 250 degrees Celsius. So these two properties is intensive property. Okay, so you can sketch PV diagram or TS diagram, up to you. Okay, so I want to sketch TV diagram because I'll choose pressure as my reference. Okay, so if I draw TV diagram, so this is my constant pressure. So if I refer to A5 at 800 kPa, the the saturation temperature I get here is 170 degrees Celsius. Given here, temperature is 250. So it means that state 2 is in superheated phase. Got it? Okay. So since state 2 is superheated, so I have to refer to table A6 at pressure of 800 and temperature of 250. So I will get V2 as a 0.29321, okay, meter cube per kilogram. And from here, I will get V2, specific volume at state 2, not specific volume, volume at state 2 as a M specific volume 2, that is 2.19825 meter cube. So WB is P 800 kPa and minus V2 minus V1. So I will get WB as a 531.8 kilojoule. Alright. So to find the answer for second question, total heat involved in the process in kilojoule. Okay. Okay. So we have a formula. First law of thermodynamics for closed system. So number 2, Q minus W is equal to delta U, and Q is equal to W plus delta U. This is enthalpy. Alright, then Q is equal to delta H. Okay, so to find delta H, I have to simplify this formula to M H2 minus H1. Okay, H2 and H1, we get this value in property table. We cannot use we cannot use the gas formula. Okay, please be careful. Find H from property table. So for H2, we know state 2 is in superheated, is a superheated, so that we find H2 at A6 table at pressure of 800 and pressure at 0.8 megapascal and temperature of 250 degrees Celsius. So that from that table, I get H2 as 2950.4 kilojoule per kg, and H1 is a mixture, so I get H1 from special formula HF plus X HFG, and this value HF and HFG I get from A5 table. Okay, so I will get HF as 720.85 plus 0.85. HFG is 2047.5. So you will get H1 as a 2461.245. Then the unit is kilojoule per kg. Q is equal to M delta H as a 338.66 kilojoule. That's all. Thank you.